Even if time were intrinsically directed, as you claim, you would still need to assume the past hypothesis to explain the arrow we actually observe, the thermodynamic arrow. And this is where the potential redundancy of the intrinsic arrow really becomes clear.
What do you mean by redundancy exactly?
Well, think about the work Sean Carroll and others have done on this. Even if you believe time has some kind of inherent metaphysical direction, a flow, there's no feature within that directionality itself that dictates that entropy must increase along that flow. It's entirely consistent with an intrinsic arrow, theoretically, that the universe could have started in a high entropy state and just stayed there, or maybe even fluctuated randomly. The fact that the macroscopic arrow we see exists because of the past hypothesis and the second law, well, it makes assuming a further, primitive, intrinsic arrow seem superfluous, unnecessary. We can explain our perception of flow, asymmetry, even causation, as consequences of the massive objective entropy increase that's dictated by the past hypothesis. We do this without resorting to positing an additional, irreducible dynamic entity that, crucially, plays no role in the time-symmetric fundamental equations of physics.
So simplicity, Occam's razor, it strongly favors the extrinsic approach here. We explain the arrow with one highly probable physical fact, the low entropy start, not two unrelated metaphysical facts, an intrinsic flow plus a low entropy start.